Hello again. In this video, I'm going to go over Objective 4 from Section R6, which is about adding and subtracting rational expressions. So when you add and subtract rational expressions, you may want to follow this four-step process they've outlined in the book. The first step is to factor the denominators and determine the least common denominator of all the expressions. Now remember, the least common denominator is the product of unique factors, where each factor is raised to the greatest power to which it appears in any denominator. Step 2 is to write the expression as an equivalent expression with the least common denominator as its denominator. And then step 3 is to add or subtract the numerators and write the results over the least common denominator. And then, of course, the fourth step would be to simplify. Okay, so let's just look at an example. Let's say you have these two rational expressions and you want to add them. Now remember, these are rational expressions because they're polynomials divided by polynomials. Now you may not think this top one is a polynomial, but that's a degree 0 polynomial, and this one's a degree 1 polynomial. Okay, and this one's degree 0 and this one's degree 2. So these are both rational expressions, and we're adding them. But you can't add them unless you have the same denominator. Just like fractions, you can't add fractions unless you have the same denominator. And so what we do in those cases is we try to find the least common denominator, or at least a common denominator, okay? But let's try to find the least common denominator. Okay, and so the way you can find the least common denominator is to factor both of the denominators that you have. So I'm just going to factor 4a. That factors into 2a, or 2 times 2 times a. And then 10a squared would factor into 2 times 5, and then a times a. And then I'm just going to write these in terms of exponents. So this is 2 squared times a, and this is 2 to the first, 5 to the first, and then a squared. And this is called the prime factorization of these numbers. And so what you want to do is you want to take, look at each of the different factors. So for example, 2, and look at the exponents that they're raised to, and you want the greatest exponent that any of them are raised to. So 2 is raised to the first here, but then it's raised to the second here. And so the greatest between these two exponents is the second power. So in our least common denominator, we want 2 raised to the highest power that's found in your numbers here, in your prime factorizations. So 2 squared, and then 5 is raised to the 1 power. Up here, it's kind of raised to the 0 power. 5 to the 0 power is 1. Okay, so there's like an imaginary 1 here that you can think of as being 5 to the 0 power. So the greatest power here would be 1. So times 5 to the first. And then a. Now a is some unknown number, but whatever that number is, we need to consider it as a factor in our least common denominator. And you can see that this one's raised to the first power and this one's raised to the second power. So we need a to the second power in our least common denominator. Okay, so then back over here, let's get the same denominator here for both, namely the least common one, the least common denominator. And so what you need to do is you need to multiply the top and bottom by the same number, but the number you need to multiply is what's missing in, as compared to the least common denominator. So 4a, okay, in fact, what you can do to make it easier, let's just multiply this out. This is 4 times 5, which is 20. So the least common denominator is going to be 20a squared. And then if I divide this by 4a, which is this denominator, notice that you get 5 and then a. And so I need another 5a, right? I need to multiply this by 5a in order for me to get the denominator to be 20a squared. So I'm going to multiply the bottom by 5a, but you have to multiply that on top as well in order for this to stay equal to 1. You always have to multiply this by 1, otherwise you change the value of the fraction. Okay, so that's what we're going to do here. We're going to multiply by 5a over 5a. Okay, now over here, 20a squared divided by 10a squared is equal to 2. So we need to multiply this by 2 over 2. Which, by the way, is equal to 1, right? So we're not changing the value of this, we're just changing the form of it. Okay, and then once you do that, you'll have the same denominator, right? This will be 20a squared, and this will be 20a squared. And then on top here, you'll get 35a. Okay, and then over here, you'll get 22 on top over 20a squared. And so now we have the same denominator, and we can add the tops together and just put it over the one denominator. So this is 35a plus 22, all divided by the common denominator, right? 20a squared. Okay, so that's how we add and subtract fractions. I mean, if this were subtracted, if this was subtraction here, you would pretty much do the same thing. You would get the least common denominator, and then after you have the same denominators for both of these fractions, you would just subtract them instead of adding them. Okay, so let's look at the next example. Okay, so in this example, we're subtracting two rational expressions. Okay, this is a polynomial divided by another polynomial, so that's a rational expression, and this is also a rational expression, right? A polynomial divided by a polynomial. Okay, but notice the denominators are not the same, so we need to get the same denominator. And so the first thing we're going to do here is actually factor. Okay, so let's factor this trinomial. First thing is to pull out the greatest common factor, which is 1. And so there's nothing to pull out. And then this is a trinomial, and it's actually one of the easy trinomials because the leading coefficient is 1. And so we just need to look at two factors of 3 that add up to the middle term. Which happens to be 4. Okay, so 1 and 3 are factors, and then that adds up to 4, so that's what we need. So it's going to factor into x plus 1, x plus 3. And then you also want to factor this polynomial on top, but they have nothing in common, and so there's nothing to factor there. Okay, except 1. Okay, they have a 1 in common, but that doesn't help us. Okay, so this one's the same way. There's nothing in common here except 1, so there's nothing to factor out. But then this is a trinomial. Again, pull out the greatest common factor, which is 1, so that doesn't help us. And you're left with a trinomial, and so you want two factors of -3 that add up to the middle term. Okay, which happens to be 2 in this case. Okay, so let's just run through all the possible factors here. Like you could have 1 and -3. That adds up to -2. And then you go to 2. But 2 is not a factor. So then go to 3. So you could have 3 and -1. And that adds up to 2. So it factors into x plus 3, x minus 1. Now notice these two denominators are not quite the same. You have x plus 1 is a factor and x plus 3 is a factor over here. Over here we have x plus 3 as a factor, but then we also have x minus 1 as a factor, okay, which is different than x plus 1. So let's find the least common denominator between these two denominators. So x plus 1 is a factor, okay, and it's being raised to the first power. There is no x plus 1 factor over here, so it's like you can think of it as being raised to the 0 power, since that's equal to 1. So we want the highest power that appears between these two denominators on the factor x plus 1. And of course it's 1, right? This is a power of 1. This one's really a power of 0. That's like an imaginary 1, right? X plus 1 raised to the 0 power is equal to 1. So that's like an imaginary 1. So the highest power on x plus 1 between these two denominators is 1. So we're going to take x plus 1 raised to the first power. Okay, x plus 3 is a factor. Okay, it's being raised to the first power here and to the first power over here. So the highest power would be the first. So we need x plus 1 raised to the first power. And then now x minus 1 is a factor over here. And it doesn't really appear over here, but again, you can think of it as being over here as x minus 1 raised to the 0 power, which again is equal to 1, so it's like an imaginary 1. Okay, and then if you compare the exponents here, this one's the biggest, right? And so it's going to be x minus 1 to the first power. Okay, so that is your least common denominator. Okay, so now we've got to make sure that both of these denominators look like this. Okay, and so what's missing over here? It's missing the x minus 1 factor. And so we're going to force that in by multiplying by x minus 1 over x minus 1, which is equal to 1, right? So we're not changing the value of this fraction. We're just changing the form. Okay, this one over here is missing the x plus 1. So we're going to multiply by x plus 1 over x plus 1, which again is equal to 1. So we're not changing the value of the fraction. Okay. Okay. And so now we should have the same denominators. Okay. So that's this denominator here on bottom. And then you get x minus 1 times 3x plus 5 on top. Okay. And then over here, notice you have the same denominator, right? That's your common denominator. And I'm going to write it in the same order. The order in which I multiply these doesn't matter. So I'm just going to keep it the same as this order. Okay. So you can rearrange the order in which you multiply these factors. Okay. So you have the same denominator. Okay. And then on top, you have x minus 5 times x plus 1. Okay, and so now what we're going to do is we're going to FOIL this out. Okay, so first would be 3x squared. The outer would be 5x. Inner would be 3x. And then the last would be 1 times 5, right, which would be 5. Okay, and then we can subtract. So I'm going to leave this. All right, so this is all over this denominator. Okay, and then we're going to subtract what we get over here. And so I'm going to FOIL, and this should be a parentheses here. So I'm going to FOIL this out. Okay, so first would be x squared. Outer is x. Inner would be minus 5x. And then the last would be minus 5. Okay, all over this denominator. Okay. Okay, now I'm just going to clean this up a little bit. These would add up to 8x. And this would add up to minus 4x. Okay, and now what we're going to do is we're actually going to subtract the two numerators. Since we have the same denominator, right, we can now subtract the numerators and put it over the common denominator. Okay, so then we have this polynomial minus this polynomial. Now this subtraction sign means you're subtracting this entire thing, okay? So I'm going to put it in parentheses. All over the common denominator. Okay, and so we have to subtract this entire polynomial, and so that's why I put it in parentheses. We have to distribute this minus sign to each of the three terms, okay? And it's just going to change the sign of each of them, okay? So this is going to be, let's write this out. This is going to be a minus x, a plus 4x, and then a plus 5. Okay, so they just change sign, minus, plus, plus. Okay, all over the common denominator. And now we can add up like terms. Okay, so 3x squared minus x squared is just 2x squared. 8x plus 4x is 12x. And then 5 plus 5 would be 10. Okay, so this is sort of our preliminary answer, but then you should always make sure that after you've added or subtracted the numerators, in this case subtracted them, you should always make sure that that you have it simplified, because it might simplify further. And in this case, I do think we can simplify it. Notice this top polynomial, you can factor a 2 out. It has a 2 in common, so let's factor that 2 out. And you're left with x squared plus 6x plus 5. And then you're left with this trinomial with a leading coefficient of 1, so we need to look and see if this factors. So we're going to look at 2 factors of 5 that add up to 6. Okay, and so you can just go through, you've got 1 and 5, and that adds up to 6. Okay, so it factors into x plus 1, x plus 5. Okay, so it's important that, again, once you get to this point right here, you need to make sure that you factor everything. Okay, that's my suggestion. Every time you're done adding or subtracting your two fractions together, you need to make sure that the numerator here is factored completely. And you can see that now we factored it completely, there are things that cancel out. And that's why it's important to factor this, because there could be some factors in here that cancel with the factors on the bottom. And in fact, x plus 1 cancels out. Okay, so that just cancels. We wouldn't have known this, though, unless we factored this. And that's why it's important to factor this top part. Okay, so the final answer simplified would be 2 times x plus 5 all over x minus 1 times x plus 3. Okay, so kind of just to recap this, when we add or subtract rational expressions, we must have a common denominator before we can add and subtract the numerators of those rational expressions. And so kind of the first step you need to do is to find the least common denominator between the two denominators, and you can only do that by looking at the factors. And so you need to factor this first, and that's what we did. We factored this into x plus 1 times x plus 3, and this factored into x plus 3 times x minus 1. And then we were able to find the least common denominator by looking at those factors, right? You want the greatest power that appears for a given factor. Okay, and then once you find the least common denominator, then you have to multiply each fraction by the factors that are missing. In this case, this was missing an x minus 1, so we multiplied by x minus 1 over x minus 1, whereas this one was missing an x plus 1. And so we multiplied by x plus 1 over x plus 1. And then once you have a common denominator, then you can subtract the tops. Okay, of course we had to FOIL this out first. Okay, we FOILed this out, and then we subtracted this numerator up here. So we took this numerator and subtracted this numerator. But remember, when you subtract here, you have to distribute this minus sign to each of the terms because you're subtracting this entire polynomial. And so after distributing that minus sign, we're able to add like terms, and we got this polynomial on top. And then you have to remember to factor whatever polynomial you're left with on the top. Because after you factor it, you may have some factors that cancel with the factors in the denominator, like we did here, right? X plus 1 canceled out. Okay. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.